Hi there, I'm Beau Liddell with Images by Beau Liddell. Welcome to part 3 of my video tutorial series on focus stacking. In part 1 I reviewed foundational concepts of depth of field and sharpness, whereas in part 2 I described what focus stacking is and scenarios where it can be used to achieve extreme depth and sharpness that simply can't be achieved when capturing a scene in just one shot. In this video, I'll outline the basic steps and provide useful tips to capture a focus stack and briefly describe some of the drawbacks, including when the technique can't be used. If you already feel you have a good understanding of how to capture photos using this technique, then keep an eye out for part 4, where I'll demonstrate how to process and generate a final stacked result. As I've previously presented, focus stacking is an amazingly powerful technique, but it does have some shortcomings you should be aware of. Although I do want to emphasize that these disadvantages shouldn't necessarily discourage you from experimenting with the technique. First, under the right circumstances, I can focus stack pretty quickly, but in general it's much more time consuming compared to capturing scenes with one shot, and it does require some planning. It usually requires the subject matter and camera to be motionless. In practice, though, and under the right circumstances, I can often accommodate some very slight subject or camera motion, but to get the best results, I want a stationary subject. Obviously, this can be a challenge when shooting outdoors. Another shortcoming is that if there's extremely close foreground elements in a composition, say within a foot of the lens, or if you've got a scene such as this where you want to capture an extremely wide depth for the final stack, but in practice can only capture a very limited depth within each shot, and if there's a lot of unfilled space between detail that you want in sharp focus, the final stacked result will show very noticeable defocus blur around edges. Here's a bad result of a 12 image stack where I was using high magnification and very wide apertures. If you look closely, you can see some of the problems with this image. But it's much more noticeable when viewed at 100%, where you can clearly see the defocus blurring where the background detail that I wanted to capture sharply is blurred around the edges of the foreground leaves. This would be very unacceptable if blown up or reproduced in a large format print. Here's the first shot taken in the set that I could use to manually mask in some of the leaf detail, but the background detail is very blurred. And here's the last shot in the set showing that the edges of the blurred leaves are defocused a lot and cover a much larger portion of the image compared to the first shot that was focused exactly on this leaf. This is what produces the defocus blurring. Because I didn't take the shot with smaller apertures and lower magnification, and didn't take enough shots due to the threat of subject movement, there was no way to use focus stacking technique to get an acceptable final result. In fact, I wouldn't have been able to avoid it, even if using f/22 in this case due to the circumstances involved. So, although in some cases we can contend with the defocus blurring problem, and I'll briefly describe how to do so later on, there are cases where serious defocus blur can't be avoided due to the nature of the composition and the physical limits of the optics. In such cases, I simply have no choice but to accept the classic depth and sharpness trade-off I face as a photographer every day. Another drawback is that focus stacking may require precision focusing devices or aids when a large number of photos need to be stacked. And finally, it requires specialized software to align and merge or blend the photos into the final output. Now that I have the limitations out of the way, I'll introduce the basic focus stacking steps. The first thing I do is to determine the composition or framing of the scene that I want in my final output. Depending on the circumstances, I might be able to capture the stack handheld as I described in part 2, but since I'll be taking multiple shots where the framing needs to be consistent, the best practice is to securely mount the camera on a sturdy tripod, locking it down well. Also, I make sure to account for the slight magnification change and hence cropping that'll be needed after the stack is composited. This requires knowledge of how the magnification of the lens being used changes as I focus from near to far. Then I determine the non-exposure related settings on the camera that I want to use, such as the focus mode, mirror lockup, drive mode, and so on. Next, I establish the white balance, ISO, aperture, and shutter speed settings manually to achieve an appropriate balanced exposure. This is especially important for the aperture setting as I want it to be the same across all shots. If I were to shoot in the aperture priority, auto ISO or auto white balance modes, the camera might make slight changes to exposure between shots that aren't necessary, and it'll either make it more difficult to stack the shots or will require I spend more time during post-processing to ensure each shot has an identical exposure and white balance. Also, I'll enable auto exposure bracketing if I'm dealing with an HDR scene. In the next step, I'll determine the total depth of field zone that I want rendered sharply in the final blended stack. This is generally pretty straightforward, and in practice I often know what I want in focus the moment that I lay eyes on the composition. Then I'll establish or at least have a general sense of the focus distances and hence the number of shots I need to sharply render the parts of the scene that I want in focus. This isn't always easy to establish, but more on that in just a minute. Finally, I'll make the captures at the appropriate focus distances. If shooting a stitched panorama, I'll do this for each position in the panorama. So these are the basic steps to acquire a set of shots for a focus stack. Now let's say we've completed steps 1 to 4. Before we start shooting though, the only thing left and arguably the most important decision with this technique is to determine the number of shots to take, with each representing a specific focus distance. That's not straightforward necessarily, and there are a number of ways that I can do that, ranging from relatively imprecise or subjective, shooting intuitively as I go, to very accurate and well planned. Therefore, I'll spend most of my time in the rest of this video describing how to determine the focus points for a stack. The hard part is to know where exactly to focus each shot within the desired final stacked depth zone. Initially, the best I can do is have some general sense of whether I'll have to take relatively few shots, say 2 or 3 when shooting landscapes with the nearest subject matter several feet or more from the camera when using wide-angle focal lengths such as here, or whether I'll need to make a lot of captures, for example, greater than 5 when the nearest part of the scene is only inches from the lens and/or when using relatively long focal lengths. One of my techniques that I like to use is to estimate focus distances by subjectively judging the depth in each shot visually, trying the best to overlap the depth zones as I shift focus to the next capture. One good way to demonstrate this approach is to show how I captured this autofocus calibration target, which required 20 captures to focus stack. The composition spanned about 1.5 feet of depth with a 200mm lens, with the front of the target located at the lens's minimum focus distance. With these parameters, the greatest, but not sharpest, depth I can capture with any one shot is about 3 inches with the lens stopped down all the way to f32. You can clearly see that the entire image has been softened due to diffraction. The blur spot diameter within the depth zone is far too large, in fact greater than 60 microns. In general, we want it no larger than 30 microns, and our eyes can easily resolve detail down to at least 20 microns. So, with this particular composition, there's absolutely no way to capture the subject sharply in focus in just one shot, and I need to either abandon it or consider focus stacking. When focused on the middle of the target, this photo replicates the roughly ½ inch of depth I see when viewing through the viewfinder or on the LCD display without using the depth of field preview button, and is equivalent to taking the shot with the lens wide open at f2.8. Here's what capturing the scene in a focus stack would look like live through the lens. To determine my focus distances, I'll begin by first focusing on the nearest part of the scene I want sharp and make my first capture. Then I'll carefully shift the focus back not quite one full depth of field zone to ensure overlap with the previous photo, and then make the next capture. I'll continue to shift the focus and make captures until I've worked my way to the farthest part of the scene I want in focus. Here's what each individual capture looks like when using an optimal aperture of f11, showing much wider overlapping depth zones. As I've discussed before, the closer the foreground subject is and the higher the magnification, the more photos I'll need to make to complete a stack, such as with this roughly 20 image capture, and the more photos I take, the better the depth of field overlap will be between each shot. As I demonstrated in part 2 on when to use focus stacking, some landscapes might only call for making 2 to 4 captures, where I might be able to get by hand-holding the camera, while others, such as these, might require over 10 shots to capture. Most close-ups I've done, like this, require at least 4 captures, and under some circumstances I might need to capture between 20 and even upwards of 80 shots, particularly for macro work. While it could seem daunting, it actually didn't take long before I could use this visually subjective approach to stacking relatively quickly and without scrutinizing each image closely. But if time isn't important and I'm shooting from a tripod, for more peace of mind, I'll either preview the depth of field prior to capture or review each shot after capture to more precisely estimate the depth of field I'm attaining. The subjective approach is what I use most of the time for both landscapes and close-up stacks and works quite well if I'm executing the technique properly. But if I'm not paying close enough attention, working too quickly, or trying to be overly frugal to save storage space, there's a risk of not capturing enough shots and skipping over depth zones, which will show up in the final blended image as noticeable focus gaps as shown here. In this case, I took one shot of the background and then one focused on the boat as it entered the scene so I could blend them together in Photoshop. This was taken about 2006, just after I made the jump from film to digital. Was just becoming familiar with layer masking in Photoshop, and I had no idea what depth of field stacking really was. My inexperience with the technique showed. The last thing you want is to capture a neat scene such as this, only to discover later during processing that you missed one or two depth zones and created a blurred, defocused band in the middle of your composition. What I should have done was capture at least one, if not two more shots focused in the middle part of the scene before capturing the foreground shot with the boat. In fact, it was my experience with this particular scene that prompted me to further explore the possibilities that digital technology affords to extend depth and sharpness. In general, the more images you make with smaller focus shift increments between capture, the sharper your results will be and the lower the risk of focus banding. So, if there are very important parts of the scene you want to ensure are captured exceptionally sharp, take extra captures precisely focused on those details, or take more photos with smaller focus shifts that covers those portions of the scene. When using the subjective approach, it's easy for me to become conservative with the focus shifts, resulting in taking more shots than I might technically need. But provided I execute the technique carefully, it nevertheless provides very good results, and often with even greater sharpness than I had planned for. Now, if the subject matter allows and I'm not crunched for time, there are other approaches that can be used to more precisely capture a focus stack. In general, if I want to be really precise, more gear and tools will be required. When needed, greater precision is terrific, and it's nice to have some of the additional options that I'll briefly cover here, but I must admit that I don't use them all that often. For landscape work, I've always been disappointed with standard depth of field calculators and tables since they don't actually provide a good assessment of sharpness within the depth zone. I mean, hey, what good is achieving some depth if it's not sharp? This happens because the typical depth of field calculation doesn't account for diffraction or defocus blur. Also, until recently, there's been no way to account for those issues and also determine how many shots are needed and at what focus distances to take them if you want to make a stack. This was solved in 2013 by the development of an app called Focus Stacker that I immediately saw the advantage of using. Now, I'm not saying you need to go out and purchase this app, which right now is only available for iOS devices. But as can be seen here, it provides you with precise distances to achieve overlapping depth zones at a particular level of sharpness based on the specified blur spot diameter. Even if I don't use a measuring device, and while in practice rarely need to focus precisely down to the nearest tenth of a foot, this application has still proven quite handy at times and reduces a lot of guesswork. In practice, I still mostly use the subjective method just demonstrated, but this application at least tells me the minimum captures necessary. And it's actually pretty easy to precisely measure focus distances by using a small handheld rangefinder and then focus on the part of the scene just measured. So with my iPod and rangefinder, I have a couple pocket-sized lightweight tools I can easily take along with me whenever I'm shooting landscapes and feel the need for extra focus stacking precision. More software utilities that specialize in or include focus stacking capabilities have come on the market in recent years, especially for mobile devices, and they make it relatively easy to use this technique. Also, many camera manufacturers have their own software utilities that enable tethered shooting on a computer where you can control focus very precisely. And finally, for some cameras, you can find customized or hacked add-on software utilities, such as Magic Lantern for some Canon models, that not only provide readouts of focus distances on the camera's LCD, but also have convenient focus stacking features. I personally don't use any of these options since what I've been doing works well for me, but some photographers really like them. If you do close-up or macro work, many photographers will use a focus rail that physically moves the camera forward or backward precisely, as opposed to changing the distance on the focus ring. In the end, it does essentially the same thing as changing the focus distance, so I've never used one, but you're hard-pressed to find many macro photographers who don't use a precision rail system, so it's something to consider if you delve further into macro work. A final precision tool that I'll talk about is a device known as Cam Ranger that hit the market just a few years ago. It's a very powerful device, and I got it mainly to use in circumstances where I need to shoot remotely without being at the camera, since it enables almost full control of the camera over Wi-Fi via a mobile device up to 100 yards away. I don't use it routinely, but it's fabulous to have in your bag when the situation dictates. Of course, it also has focus stacking capabilities where you can either manually stack by using the touchscreen on a mobile device or use evenly spaced focused increments using the automated stacking feature that I use to capture this 25-shot stack. During the last part of this tutorial, I'll briefly present some tips and best practices that can make capturing a focus stack easier and will improve the success of the final post-processed image. Remember, your subject matter must be registered between shots, so avoid windy days when shooting outside, particularly if there's any vegetation in the foreground or other subject matter that could move from the slightest wind. If shooting ultra-wide angle field of view and only needing to take 2 to 3 shots for a stack, then you can still get acceptable results if there's very slight wind, but it's best to avoid stacking when wind is present, in which case your only option to capture the scene and maximize depth is to take one shot using hyperfocal distance technique with the most optimal aperture. Just to send the message home, if you try to focus stack with subject movement, you'll get strange ghosting in the composited stack as shown here. Obviously, it'd be a waste of time trying to correct this in post-processing. As already mentioned, use a solid tripod and head if possible to keep the camera's framing consistent among all shots in a stack. Don't use image stabilization when shooting from a tripod, as it may well introduce vibration during capture. And if shooting handheld for a 2 to 5 shot focus stack, pay extra attention to your holding technique to minimize rotational, side to side, and fore aft movement between shots. If shooting from a tripod, especially with slow shutter speeds, use a cable release or your camera's 2-second shutter delay setting if equipped to prevent causing vibration blur from depressing the shutter button. Avoid blur caused by camera vibration at slow shutter speeds and by mirror flop if shooting with a telephoto lens by enabling mirror lockup or shooting with the live view if your camera is so equipped. If you have the time, consider taking at least 2 shots at each focus point. The extra shots can be used as insurance against slow shutter speeds if you're hand-holding the camera or bump your tripod. Also, if there's some slight subject movement, you'll have additional photos to choose from and might be able to find an acceptable one that you can stack or manually blend and hence contend with subject movement and prevent any ghosting that might otherwise occur. Use the quick control screen on your camera's back LCD display if your camera has it. It's much easier to see your aperture, shutter speed, and ISO settings here than on the LCD panel on the top of the camera, especially if the camera is positioned very high or low compared to your normal viewing height. I've mentioned this already, but you're going to get generally better and more consistent results if you set your camera to manual and shoot each photo in a set at the same picture style, white balance, ISO, aperture, shutter speed, and focal length. For maximum image quality, contrast, and color saturation, use the optimal or native ISO setting whenever possible, which should be between 50 to 160 for most cameras. If you're worried about stopping subject movement, remember we don't want any movement anyway. If your subject is static as it should be, and you're shooting off a tripod, then slow shutters won't be an issue at all. If you're hand holding the camera with shutters slower than 1 over the focal length, then boost the ISO just enough to obtain the shutter speed you need to prevent blur caused by camera movement. As already mentioned, if the scene's dynamic range can't be contained by your camera sensor, enable auto exposure bracketing feature and disable the bracketing auto cancel. If you're hand holding the camera and the exposure time for the lightest bracketed exposure is too long to prevent vibration blur, then increase the ISO setting just enough to obtain the needed shutter speed. Shoot in your camera's RAW file format, or if you don't normally process your photos, still shoot both RAW and JPEG. If your exposure settings are correct, you can blend the JPEG files straight out of the camera if you don't normally process your photos. But you'll have the RAW files as insurance in case you made an error and need to go back and make adjustments. Obviously, if shooting landscapes or close-ups outside, work as quickly as you can to capture the stack before lighting changes. As I mentioned earlier in this video, there are circumstances where you just can't focus stack because of defocus blur. But there are some circumstances where you might experience defocus blur, but can still achieve a successful stack. Although you'll get poor results if you don't fully understand defocus blur and when or how you can contend with it. So I'll cover that briefly before we close. There are a number of ways to try and eliminate defocus blur problems. Obviously, using shorter focal lengths and the smallest aperture that'll also provide the desired sharpness, such as shown here, will result in greater depth, greater overlap of the depth zone between shots, and as a result will minimize, if not eliminate, the risk of defocus blur occurring around the edges of key foreground subject matter. It'll also reduce the number of shots you need to capture, although, as stated earlier, taking a few more shots than you may need technically is a good practice if it'll actually provide you better results, including minimizing defocus blur problems. Shots like these also demonstrate how either the natural juxtaposition of foreground elements in a scene or how you choose to compose and position the foreground can eliminate or reduce defocus blur in the final output. The farther away the closest foreground elements are from the camera, the more fully contained in the depth zone they'll be, and the lower the defocus blur will be around the edges. Repositioning just another couple inches to a foot farther from your nearest subject matter can actually make a big difference in this regard. Also, the less vertical span that foreground elements cover in the composition, the less you'll have to contend with defocus blur. As you can see, the foreground vegetation in these shots is short and doesn't encroach much into the middle or background detail, so it was easy to blend these without any defocus blur in the stacked result. Related to this, the less dead space there is between the foreground elements and the backdrop that you also want in focus, the less chance there is of defocus blur problems. Finally, if you want a soft background, such as when taking close-ups such as this where the backdrop behind the orchids is meant to be blurred, or if the background otherwise contains no details such as a cloudless sky, then defocus blur will not be a problem for you. The final way that I can thwart defocus blur in a final stack is more sophisticated or complicated and also more time consuming, but it's a good technique to try if you have no other means to achieve your vision for a scene. While I maximize the final output pixel quality for producing a large print by using optimal apertures, there are times when it's actually prudent to take additional photos using the smallest apertures, regardless of the effects of diffraction that I talked about in part 1. If the scene might produce defocus blur problems, I'll still stack it using optimal apertures, but will also try taking at least one, if not several shots focused at different distances with the lens stopped down to between f16 and f22. If I can get the defocus problem areas of the scene within the depth zone of a shot using suboptimal apertures, then I might be able to correct the blurring around the foreground edges during post-processing. A good way to illustrate how I approach this is with a simple composition under controlled conditions showing an initial 8-shot focus stack where the depth captured was about 5.5 feet with a 24mm lens at the minimum focus distance just under a foot and an optimal aperture of f8. I've cropped into the relevant part of the scene so you can better see the edge of the foreground flashlight. As you can see, the original automated focus stack on the left shows a fair amount of defocus blurring around the edge of the flashlight, and I got this result no matter what program I tried to use. In the image on the right, I manually adjusted the layer masks to correct some of the automated blending errors that occurred. I clearly improved the result in the process, but there is still defocus blurring around the edge of the flashlight and is most apparent if you look closely at the top edge of the foreground flashlight where you can see blurring of the white letters in the background. So these circumstances mean the scene couldn't be captured and stacked successfully by taking shots only at f8. After capturing the initial stack, I changed the aperture to f22 and then took a few shots focused at different distances so I had a couple of shots to choose from, although I also could have stacked those as well. Then I simply masked in a slight portion of the flashlight's edge and immediate surrounding space from one of the shots taken at f22 as shown in the black and white layer mask on the left to produce the final blended image on the right that didn't have any defocus blurring. Usually I don't have to be all that precise with the mask, but the main point is that I've removed the blur and retained all the sharper pixels that were captured when I stacked the scene with the f8 shots. Yes, technically the pixels immediately on and around the subject's edge are a little softer than the surrounding detail, but overall it's not noticeable and it's much improved compared to the original stacked result. So that pretty well covers the nuts and bolts of how to capture a focus stack and the tips that'll improve your success at using the technique. I hope you found something useful, and if you have any questions about what I covered, feel free to send me an email at imagesbybolin@charter.net, add a comment below this video, or you can visit my website at imagesbybolin.com and click on the contacts link. Thanks for watching.